Here's a sinusoid. Let's add a horizontal axis right down the middle and call it the time axis in seconds. Add a vertical axis, call it volts. Because I've added these two axes in those positions, that makes a cosine function. Let's pick omega at 10 radians per second. And since omega is also 2 pi f, where f is frequency in cycles per second, or hertz, and also omega is equal to 2 pi divided by capital T. Capital T is the period. The period is this amount of time for one cycle. That amount of time is the period. Now let's calculate the period. Let's calculate the period. It's 2 pi divided by omega. 2 pi divided by 10 radians per second is 0.628 seconds, or 628 milliseconds. 628 milliseconds is this amount of time. Half of that is 314 milliseconds, and half of that is 157 milliseconds. We'd like to know what the time is when the voltage is half of Vm. What are these three times? The times when the voltage is Vm divided by 2. Well, divide both sides of the equation by Vm, and we see that cosine of omega t is 0.5. Take the arc cosine of both sides. Omega t then is 1.047 radians. Divide both sides of the equation by omega, and we see that time is equal to 0.1047 seconds, or 104 milliseconds. 104 milliseconds is one of those times. Which one? Well, it's obvious that it has to be this one. So this time is 104 milliseconds. By symmetry, this time is also 104 milliseconds, that time difference. 628 plus 104 is 732 milliseconds at that time. Since that's 104, by symmetry, this time difference is also 104. 628 minus 104 is 523 milliseconds at that time. In summary, it's 104, 523, 732. Those are the times at which the voltage is Vm divided by 2.